All right, so I'm going to have to clap my hands so the recorder's all synced up. All right. I don't have any introductory slides. So back during the R conference a few months ago, Jared had asked me, or he made a comment about how the R meetup, although great, some of the topics are getting a little more advanced, and it kind of snowballed into something that became too complicated for someone just starting R. And so he had asked me to do something to like bring it back to the basics, as he called it. So I decided what's something that's relatively like an introductory topic into R, but still feature rich. And so those of you who are experienced in R can also hopefully learn something from this talk. So what is R markDOWN? It is using markDOWN, which is essentially shorthanded HTML, and it allows you to write documents or presentations. So this presentation right here is actually written in R markDOWN, or really in RStudio. And so you get stuff like, this is an R markDOWN presentation, so this is something that you're very used to if you're using PowerPoint. And you can do stuff like bullet points. So this is the default, when you create an R markDOWN slide, this is sort of the default text that sort of shows up. So you have stuff like bullet points, just like every other PowerPoint presentation thing that you have. What's cool about it is you can then also write R code, and then it will spit out, it will show you the R code that you wrote, and also you have the option to show the R output. So it allows you to interweave regular R code, its output, and prose text. So, and the same thing works with plots. And so this is something called literate programming. That's the technical term if you were to try to Google this on your own. And it's simply a way that, it's a technical way to say, hey, I have code and I want to be able to talk about it all in one document instead of running my code, saving the output, copy, pasting it into some Word document, and then you have then you run the risk of some plot not being up to date after you ran the code or not. So all this happens in one document, so your plots are always up to date, your interpretations are always up to date, et cetera, et cetera. So this talk is going to be a general introduction and overview into R markDOWN. So the first thing you want to do is within RStudio, under the global options, this is sort of what I do just for general practice. Under the first Generals tab, I pretty much uncheck everything at the top in that first block. Essentially, it is essentially what the check marks or the options say is whether you want the previous state of RStudio to load back up when you open up RStudio. Why is this sort of bad? Well, sometimes when you're working with really large data sets, this can, you have like a multi-gigabyte file that's loaded up into memory. And if you close RStudio, if you're working only on that one project, it's fine. If you open up RStudio, you get the exact same state back. But there are going to be times where you just want to open up RStudio to do something simple, and you don't want to wait the 30 seconds to a few minutes just for it to load up its previous state. And it's also a good practice that you probably shouldn't be relying on a previous state anyway. You should always be able to retrieve your previous state from the code that you write. So that's just a general, I guess, good practice that I would suggest. The other thing with R markDOWN, so for me, I find it, I think it's a bug, I'm not really sure, but by default, the code section has the tab width to 2 spaces. But if you work in markDOWN documents, if you try to nest bullet points, for example, 2 spaces doesn't actually trigger the markDOWN rendering to nest a bullet point, so you actually need it to be 4, so that's why I changed the tab width to 4. All right. So just a general overview of markDOWN and what it is. There is a set of cheat sheets that are built into RStudio. So if you have RStudio open, you can go to Help, Cheat Sheets, and essentially I'm going to do a little walkthrough over the R markDOWN cheat sheet. And this is sort of an excerpt of what that looks like. So what is markDOWN? You can have plain text. So the left panel here is what you would type into the document, and the right panel here is what will actually get rendered when you render the markDOWN file. So you can have regular plain text and it'll render into plain text. You can have text that spans multiple lines, or if you want a line break, it's 2 spaces at the end of the line to force a line break. You can do things like italics and bold simply by surrounding the words by 1 star or 2 star. Quoted or verbatim code, so code that looks a little bit different. You kind of use this if you're trying to show that this is a block of code. You can surround that block of text with backticks. You can do things like strikeouts or superscripts or subscripts. And the other cool thing I want to show or point out is the headers. So you can have a single hash to make a larger block of text, and that goes all the way up to 6 hashes. And you kind of use this throughout like all of the things that use markdown. All right. And on the right panel, this is sort of just on the actual cheat sheet, a really long part of the page. But you can have ordered lists or unordered lists. And you can see the rendering after it gets rendered on the right-hand side. Tables, you can also do tables. I almost would only suggest if you have a simple table, write it in Markdown. Otherwise, I kind of just write it in pure HTML. I need to silence my phone. All right, cool. So what makes R Markdown a little special? So how do you get started with R Markdown files? Like I said, this is literate programming, so that's interweaving code, its output, and regular prose text. And the way you would do this in R is you go to File, New File, and then there's an option for R Markdown, and you get a little pop-up window like this. If you don't have, I guess, the R Markdown package and other packages installed, it'll prompt you to install those packages right then and there. And so when you create the new R Markdown file, this is essentially what you would get. So I created one for slides, and this is just one for a regular document. And there's essentially 3 main parts to an R Markdown file. You have here at the top, that's the YAML header, so YAML header. That's just options that you give the when you try to render R Markdown. These colored in blocks, those are the R chunks. And then this white text here, that is the regular prose text that you can write. And so, for example, this is the YAML header for the current presentation that you're looking at. You have a title, you have a subtitle, there's the author, here's the date, and then down here is the type of documentation or type of document I'm creating using R Markdown. In this case, I'm using one called Reveal.js, so this is a presentation slide called Reveal.js, and it's cool because it gives you horizontal and vertical slides to work with. And I'm also showing you this because Reveal.js isn't built into the R Markdown installation. You actually have to install it separately as its own R package. So it's just more of an addition to what's going on from the default stuff that R Markdown gives you. And so what are the different types of output? So this type of output is the Reveal.js presentation, but you can have an HTML document, a PDF document, a Word document, open document text, so that's like LibreOffice or OpenOffice. The bottom ones here, those are the different types of presentations that you can create using R Markdown. And what's cool about it is this is only specified in the YAML header, so the first couple of lines in your file. So you can easily swap between one type to another. So if you're trying to go from like a PDF document to a Word document, you really just need to swap out like one keyword. Typically what will happen when you're starting out is you'll probably working with an HTML document. That's the default one that usually pops up. And another one that's pretty useful is the GitHub document. This isn't in the drop. When you create a new file, it's not one of the options you can select, but GitHub document is one you can manually type in and comes with R Markdown. And what's cool about the GitHub document is if you work in GitHub, you can create a README file using R Markdown, and it'll properly render a GitHub documentation file for you on the main page. So if you're trying to say, hey, here's some R code, here's the output, you can have GitHub, you can exploit or use GitHub's automatic rendering of Markdown files, and you can write all of that in R Markdown itself. So here's the different types of output options. So for each type of output that you have, you can tweak it in some way, shape, or form. And so you can see why HTML, that format is so popular or used a lot is just because there's so many different ways you can handle the way it's rendered. Stuff like PDF, there's less options involved, but some of them kind of make sense. Let's see, like the keep tech option. So this is a PDF file that gets rendered using text, so it doesn't make sense to have, so it makes a lot of sense to have a tech intermediate file versus when you're creating an HTML file, it doesn't make any sense to have a tech intermediate file. So these are the various options that you can place in the YAML header. All right, so what I talked about was all the stuff that you can put into this, in this case, the first 5 or 6 lines of code. So that's all options that you can put into the YAML header. But let's discuss a little bit more about the actual main document itself, so the body of your R markdown document. The first thing you'll notice are R chunks. So you can write something like 3 backticks, a set of curly brackets, the letter R, and then some R code, and then what you will get back is the R code itself that you wrote, and then the output of the R code. And then you can write your interpretation right underneath. So you can say, the previous slide showed random draws from the normal distribution with mean equals 0 and standard deviation equals 1, and there were 10 draws. Right, so that number 10 was actually dependent on the actual R code itself. So you can either manually type in the number 10 in your documentation or your prose interpretation of it. You can say, hey, there are blank draws, and put in your R chunk of print n, which was 10. Or you can run inline R code straight into the prose text itself. And the way you would do that is you have a set of backticks. So backticks signal that this is going to be a special type of text, typically code. And if your backticks begin with the letter R, then that will be actual R code that gets executed. So what this number 10 here is really backtick Rn. So I'm not hard coding the number 10. So if I were to run this previous slide, and if I were to change this number, this slide would automatically update itself to however many number of draws I want it to make. So this is one way, especially when you're interpreting or writing interpretations that depend on the output, don't hard code or don't manually type in the outputs. You can write your R code so your documentation is always up to date when you run your R markdown document. And so these chunks or these blocks of R codes, they also have their own options that you can feed it. So you can begin with a very simple or basic R chunk, which is 3 backticks, a set of curly brackets, the letter R, and then your R code in between, and then you close it off with another set of 3 backticks. If you have a lot of different R chunks, and if you'll notice in RStudio, there's a sort of like a table of contents viewer for chunks. You can give your chunks a name, so you can easily jump to specific or special chunks. So if this is, you can leave most of them blank, but then if there's one chunk that's like generating our plot, for example, you can give that chunk a name, so you can easily toggle or flip to that chunk itself. And then if you want, you can, using a comma, you can specify different options. So this one, I have echo equals true. So echo, what echo is doing is, if you look at the cheat sheet, display the code in the document, in the output document, right? So sometimes you want the code to show as well as along with the output, or if you set echo to false, it won't show the actual R code, but the output would still be rendered. And there's an option for output somewhere. I guess it's under one of the options not listed, but there's an option to like just run the R code and hide the output. Sometimes you need that, especially when you're writing presentations and you need to fake something going on. That's probably something that you would do. And so there's like a block in the actual cheat sheet for the different options.
Actually, would you go over the ones that have caching in cache?
Oh, cache. So what caching does is R tries to, it's not always successful, but it tries to determine whether there was a change in that R chunk or any code that chunk uses above it, and it'll try to save its results. So if I take it to one extreme, if there's one R chunk that takes an hour to run, and you set cache equal to true, and none of your code changes, it'll just take whatever was ran before and just use that result. It's not going to try to run that hour-long calculation again. So that's what the cache is doing. And all of that stuff has to be saved into some kind of directory, so that's what the cache path is doing.
If I wanted to save, let's say, read CSV, sometimes it's very large.
Mm-hmm.
I would specify cache equals true, and I would specify comma cache path and tell it where to look.
Oh, no. So if all you're doing is trying to load up a CSV that's taking a long time, you can set cache equals to true, and it'll save whatever our binary object into cache. You don't have to specify the cache path. By default, it's wherever your R markdown file is, it'll create like some kind of hidden folder, and all of the cache information will get dumped in there. So if you're just thinking about caching stuff, you can just use, you don't have to specify the cache path. That's if you want your cache in a specific folder, not in the current working directory. That's
Okay.
Yeah.
And this caching will, so it actually remembers the previous time you did the knit.
Yeah, well, it tries. If you do this enough, you'll realize that the caching doesn't always cache, or sometimes when it's out of date, it doesn't always remember that it's out of date. It's great if you're trying to just get through writing a document. You can rely on the cache, but typically if you're like submitting something for a final report, you should probably get rid of all the cache and make sure everything runs properly from top to bottom. So, but yeah, your mileage will vary if you're trying to cache things. It's actually pretty hard to tell R to mark something as out of date. So when you're working with R Markdown, there's this magical blue button in RStudio that says knit. And you can knit the document either by clicking that button or using Control-Shift-K as a keyboard shortcut. But sometimes when you start working with larger projects and you're trying to knit things, you need a little more control than what the knit button gives you, or you need a lot more control than what the little gear option that lets you tweak what the knit button gives you. And so what the knit button actually is doing is calling this function called render in R Markdown. And this is just the actual function definition of what the render function is doing. So when you click knit, the current R Markdown file that you're in gets automatically input to the first parameter, which is for input. And then you have a bunch of other parameters that you can set.
What knit with parameters are?
Oh, knit with.
I'm getting something here that says knit with parameters.
Oh, I will cover what knit with parameters is in a bit. But yeah, so if you need to, for example, run your document in like the command line just because you don't want to open up RStudio just to run something, you can just run it in the command prompt. You would essentially call this render function directly. Just something to keep in mind, if you're just starting off, just click the button. That's what I did. And then sooner or later, you're going to end up running into the limitations of that nice blue button. And this actually took me a surprisingly long amount of time to figure out what that button was actually being called. So I'm instilling my knowledge onto you guys. It's actually the render function. OK, so parameters. What is parameters? Parameters allow you to essentially give the entire document some kind of variable, and then you can use that variable throughout the document. Something, I think in a lot of the demos, you can put in like a date there, so your document will just render with whatever date you put in. So here it says demo 01. So hopefully I have this all set up. All right.
Okay, so if you specify a particular date in that YAML, whatever, at the top, let's say today's date, how will you use it within the R?
Yeah, so how would you end up using the variables that you specify in the YAML header? So this is a document that right now I just say, hey, I'm going to have some parameter. It's going to be this. One of the parameters I'm going to give it is just a variable called data. So this is something you can just create on your own. You can call this pizza if you want, but I'm using data. And so here's some code in my document. So I can say, hey, if I want to use the value in here, it's a special variable. Params is a special variable that you have available to you. And if you say, hey, from my parameters, I want the data, you would just get to it by using the $sign. So if my parameter is called cars, I'm going to say, hey, load up the cars data frame into a variable called df. If my parameter is empty cars, then use the motor trend car dataset, load that into the df variable. Otherwise, just use the ggplot diamonds variable. So in this example, if I click knit, because I didn't specify cars or empty cars in my dataset, what should happen is the diamonds dataset gets loaded. So if I run knit, so this is that blue button I was talking about. Those of you who have some familiarity with R would notice that this right here is the diamonds dataset. But if I had said right here, say cars, and I run knit again, you'll see that it picks up the variable cars and will now use the cars dataset instead of the diamonds dataset. So this is one way where if you're swapping up datasets at the top of your document in your RMD code, in your RMD file, you can specify those variables in params. And so just to finish up the example, so I can say empty cars, knit the document, and it'll pick up the empty cars variable and just run empty cars, and that's the variable that's the data frame that's being used down there. Yeah.
Are the other YAML options exposed in my
I think it's just parameters. The other YAML options, I don't think I actually show you guys this. Maybe I do, I'm not sure, I don't remember. But I'll link to it at the end if I forget. But yeah, so the other YAML options, so within knitter, you can say knitter like chunk op or document op, so you can change those options that way. So
how would you use date? Let's say you put them, right now it's nothing, is that?
yeah, right now I left the data as nothing.
Then you put them today's date.
So this date here, I have no idea what's today's date, 26. The actual YAML parameter date will be part of the title. If I had wanted a separate variable called date, so something kind of that you'll see, I don't remember. Can't always live code everything. If you wanted, for example, to have R automatically pick up today's date, there is some R command, I think it's sys.date. Yeah, so if you really wanted to make sure that whatever date you don't have to hard code anymore, I believe it's a comma. You can put in like a block of R code in there, and it will just, you can use that variable date inside your document if you need to. All right, cool. Where's my presentation? Oh. That's interesting. Okay. Did not realize it does that. Okay. Where am I? All right. So just like with running render, so that's what the params option does in render. So if you have to pass in parameters through the command line, because this R document that you're creating is just one piece of a larger pipeline, you can create these variables when you run the render function. So when you start running these things in the command line, you're going to notice that you're going to have to use pandoc and pandoc cite if you're going to try to reference things. If you have RStudio installed, I believe all of this stuff comes with it, so you don't really have to install this stuff manually. But just keep in mind, what's converting this R markdown document into all of the various other types is really a program called pandoc. And so if you really needed to run something from the command line, you can say rscript -e So R script is how you actually run R code from the command line. This -E says, hey, I'm not going to run an R script file. I'm going to actually call R code directly from the command line. And so here, this is the render command. And if I were to run this, should I try to do this? Let's, why not? 2017, 26. Nope. All right. So if I were to run this, of course there's a mistake. I wonder if it's also because of these spaces. So let's try this again. Oh, look at that. So what did I do? I passed in empty cars into the render function, and you can see it actually generated this document from the command line, and it passed in the empty cars data set. All right, so what else can R markdown do for you? There's a bunch of other stuff that you can look up using the actual R markdown website. So what I actually like to do when I teach or try to give other people tutorials is actually just link to the actual documentation, because most of the time, a lot of your questions can be answered by reading the documentation. But if you're just starting out, reading the documentation is kind of like scary. So this is sort of why I gave you snapshots of the actual cheat sheet, so just to walk you through it so you can learn to read it on your own. But there's also this new thing called notebooks. There's stuff like this called slides. You can create interactive documents. You can create dashboards using R markdown. You can create websites using R markdown. And you can create books using R markdown. So notebooks. What is an R notebook? So I want to say here's the background behind R notebooks. So in the Python world, there used to be this, or there is a thing called the IPython notebook that is now called the Jupyter notebook. And so the R notebook is sort of the R Studio version of that Jupyter notebook. So, and the main difference to go from a R markdown document to an R notebook is in your YAML header, you change HTML document or whatever into HTML notebook. And for those of you who are familiar with the Jupyter notebook, what's cool about it, or some people like it, I actually hate it, but the output is underneath your block of code. Which is, especially if you're teaching, it's nice, but if your output is really long, I actually prefer the output to be in the console and not just run off my screen. But one of the benefits is the output is underneath your block of code. In the R markdown document, there's a typo there, all of the R code is sent to the console at once. So when you knit the document, you essentially start off with a blank R session, and it just runs from top to bottom. I like that. I like that feature. It makes sure that like my code is doing exactly what I'm doing, especially if I'm just writing code along the way. But it can be time-consuming especially if your cache stuff isn't working out. So what the notebook is doing is one line gets sent to the system at a time, and the output is just rendered underneath. You get slightly better error handling because it will break exactly where your code is broken, versus you get some like weird like output message from R markdown sometimes where it's just like, hey, something didn't work. Here's some error message. Here's vaguely where the problem is, right? And the other difference is there's a difference between knitting a document, which is what you get when you use any of the R markdown stuff, and then previewing a document. So what's cool about the R notebook is because all of your code, and if you have it set up that the output is underneath your code, it doesn't have to render that again. All it does is when you are previewing a document is it's taking whatever you have in your R markdown view and it just dumps it to an HTML file. Oh, so I think I can, hopefully I have a demo. I'm pretty sure I have a demo. Was there a word demo to prompt me that there's a demo? Oh, okay. That's 02. All right. So this is in our notebook, and you can see at the top in the YAML header, it just says output HTML notebook. And right now, if I run this, you can see that the plot actually got rendered underneath my block of code. This does not happen if you aren't using the R notebook feature. And up here, you can see you get the button preview instead of knitting. So when you're knitting, what actually happens is, think of it as you open a brand new session of R and it executes every block of code from top to bottom. When you're previewing a document, so right now I already have this plot rendered, this calculation already happened, so if I hit preview, all it's doing is taking whatever view I had in RStudio and creating an HTML file. So there's no time, so it doesn't take any time to actually generate this HTML file. Versus before, if you wanted that HTML file, you actually have to wait for R to execute every single block of code. So it's sort of a quicker way to getting a document if you already have all your code executed. Yep?
Can you do a normality test right there for the data?
A normality test?
Yes, like you see the data normalized or?
Do you know the R code for that? Wait, say again?
QQ plot?
Oh. Do you know what to tell me the type?
Or just say that
I am not. Wait, a QQ, so then I have to put in like I don't know how to do this off the top of my head. But you can, and whatever ends up getting dumped out, you can click preview and it will create the document right away, so it doesn't have to do those calculations. All right, any other requests for live coding? No? Okay. Oh boy, I need to stop hitting this knit button. Actually, I should.
What exactly? I've heard about Jupyter notebooks. I haven't used them. I use markDOWN all the time. I use knit, but what is the difference between when you create a notebook?
Mm-hmm.
It's still HTML code.
It's still HTML. The main difference between, well, the obvious difference is when you are creating an R markdown document to in our notebook, is creating the HTML takes 0 time in the notebook, but it takes however long it took to execute your R code the other way.
Okay. When I'm writing code, I often run a chunk at a time in console and see how it's working before I try to knit. But I often jump around and I put in the code. Would that totally confuse it?
So it won't. So if you're like me and you code all over the place when you're creating these documents, this is sort of why I like the older original paradigm, is because when you knit it, it starts from a clean start.
Right.
Versus the old way, whatever is on your screen at that time is what gets rendered. So if you wrote some weird code or did some weird thing, and you jumped around, that whatever is on your document, that's what gets rendered. So yeah, I prefer it the old way, but there are some cool things about the R notebook, and one of them is, so in both cases you can use various other languages. So this is an example of writing raw SQL, so you don't have to, I don't know, use the R command to query a database. So I also have this data set. So this is a data set from the software carpentry SQL lesson, and I believe it's under Creative Commons, so I can take it. And so you can see instead of the letter R in this chunk, you can say SQL, and you create the SQL connection in R. You can pass that connection into the connection option in the code chunk, and then in here you can stop writing R code and just write raw SQL strings, and you will get whatever thing back. Yep.
Can you create a connection as well, or is it all?
So the SQL connection database is here up here in regular R code world. So this is the R code to create a SQLite connection.
But that's SQLite, Microsoft SQL.
Oh yeah, so you can use like R PostgreSQL, R MySQL, R Oracle. I'm pretty sure there's a Microsoft version because they bought Revolution Analytics. So there's different libraries for it. This just so happens to be using a SQLite. Mhm. So that's really cool that you can write raw SQL and you get a table back. But there's an option called output.var, and if you give that a variable, whatever comes out of that SQL string gets loaded to that variable in R. So how if I actually, so now I should be able to run stuff and it'll be totally fine, right? All right, so I created my SQL database. I can execute raw SQL, and the output's a little prettier in the notebook. That's another thing you'll notice. What I can do is, for example, here, I'm saying, hey, whatever comes out of this R chunk, save it to the R variable df_SQL. So this is the same SQL query as before, but instead of dumping the output to the screen, it's now actually saved to that variable in R. So you can write a SQL query without all the weird R stuff around it, save it to an R variable, and then just use it and continue on. So that's one of the cool things with the notebook that you can't really do with the R markdown document. And you can do things the other way around too. So let's say I have this string variable called name, and that's in R, and I want to use it in my SQL chunk. The way you can reference an R variable is you use the question mark and then the name of the R variable. So here, this is select everything from the person table where personnel is equal to whatever I had set the variable name to in R. And so if I run this, if I query it again, you can see that it only returned whatever that SQL string matched. Cool. All right, I went over that. All right, slides. This is a slide. It's not any different from the R Markdown, R Notebook stuff. You get a few built-in slides. So there's one called I/O slides, which is, I think, is the prettier of the. It's prettier than Slidey, but there's another one called Slidey. The presentation deck I'm using is called Reveal.js, and if you want to install it, here's the code to install it. And you can also create Beamer slides if you need PDF slides. And in this case, all you do is really changing the output parameter in the YAML file to whatever you need. So I'm using the Reveal.js presentation, but if you had turned it into I/O slides, you'll get a different slide deck template. HTML works too, so Markdown is really shorthanded HTML. So you can write raw HTML if you really need to. So the pictures that I had before when I made 2 columns, here's the CSS for making 2 columns, and you can write the raw HTML to split something into 2 halves. This is also pretty good for more complicated tables. So if you ever try to write a long or wide table in Markdown, it's ugly and confusing and not really. You're not going to have a good time. So sometimes if you just need a table, it's actually sometimes a lot easier to just write the thing in HTML. All right, interactive documents. When I show interactive documents, or actually when I try to teach Shiny, interactive documents is usually the way I try to introduce how to program or create a Shiny dashboard. The cool thing about it is if you're trying to make something interactive, like you have a widget or a drop-down menu to pick a different reference distribution for a QQ plot, for example, you can build that into your document. The cool thing about these documents is you don't have to write all of that weird boilerplate or just code you have to write to set up Shiny. So I do have an example. So this is if you go to File, New File, R Markdown, if you go to Shiny, this is the default Shiny document page that shows up. And the main difference here in the YAML header is you have now this runtime argument, and it's set to Shiny. And instead of knit, you get this run document button. And so if any of you guys haven't ever seen a Shiny document before, this is what it is. It looks exactly like that RMD file, but now you get to pick different widgets that are now tied to the base of the underlying R code. So you can have a little more of an interactive document. For those of you who know how to build full-blown Shiny applications, you can take that entire application and just embed it straight into the document as well. So you don't have to rebuild something if you already did build something. And pretty much, yep.
If you create this interactive Shiny document and then you send it to somebody who doesn't know R, doesn't know Shiny, will they be able to interact with it?
Oh, yeah, so how does this, so if you create this interactive document, how do you actually interact? I believe the only requirement is they're gonna have to have, the easiest way would be you have to have R, RStudio, and Shiny installed. Because when you are making those toggles, it's actually executing or re-executing R code in the background. So the nice thing about these HTML documents is you can just give it to anyone else. But when it's interactive, because there's R code being executed, they actually have to have R and all of that stuff set up or installed. Or you can have a server. Yeah, so you can have you can have a Shiny server all set up, and you can upload your document there, and they can view it in the browser there. But yeah, so this, just to show you guys the two little panels. The one was a drop-down menu, and the other was a slider, and then that whole thing was in a nice little panel area. That's pretty much all the code you need to write to define that panel area, and then the plot underneath. That's all you have. That's really all the code you have to write to link all of those two things up together. And if you guys have ever programmed in Shiny, that's a lot less typing than building the actual Shiny application. Since this isn't a Shiny tutorial, I'm going to move on. So you can do the same thing with presentations. I don't have a demo for this, but if this was something that I needed interactive widgets with, you could also put in a Shiny app into a presentation, which, I don't know, I feel like your boss may or may not like that. So, so how to make dashboards. So I showed you how you can make Shiny or interactive documents. You can also create dashboards, so full-blown Shiny dashboards in our markDOWN or using markDOWN, and that's using a system called Flex Dashboard. So here's a link for that. I think I actually have those as.
Is that stuff HTML that you can send to somebody who doesn't have R?
So these, where are my slides? Oh, that's weird. I just opened it in there. Uh-oh. What did it do? Oh, there it is. So these Flex Dashboard things, it's still, anything interactive is going to need an R server under the hood. So it's never going to be as simple as here's an HTML file. You're going to have an R or Shiny server running in the background. But the cool thing about Flex Dashboard is you can use markDOWN to define how you want to split up the window. And you get these really nice, pretty much like full screen dashboard applications, which if you were to try to do this in base Shiny or even Shiny dashboard, I don't think you can get the actual like edge to edge like full screen version of it. So here's one example of what creating a Flex Dashboard looks like. Here's another one, and then here's another one. So it takes up the entire screen. So if it's one simple or one story that you're trying to convey, Flex Dashboard is a relatively easy way to specify how to lay out the screen without writing all of the weird Shiny code to set up the UI stuff. Right, so markDOWN is it is writing HTML, so you can actually, it's fairly new. You can actually create your own websites using our markDOWN, and RStudio has done a really good job integrating all of this stuff. And it's using a system called blogDOWN. So a lot of people have GitHub web pages. GitHub uses a system, well, GitHub supports or by default uses a system called Jekyll to host static websites. markDOWN uses another system instead of Jekyll. It's using one called Hugo. But you can use markDOWN to create GitHub pages or any kind of website or web page that you need, and you can install it by installing markDOWN. Because markDOWN uses Hugo, they actually built in a quick function to install all the stuff you need for Hugo. I would suggest if you are creating a website, create it in a separate R project, but you can create all of the random files or the template stuff by using the new site function. So just auto-generate all of the base files that you need for a website. And then you can run the website on your local computer by using the serve site function. And so So this is one example of a markDOWN website. I think this is just from the main actual documentation, but there are many other prettier examples. That's just something I wanted to cover. I personally still use a Jekyll website, so I haven't converted everything into R using markDOWN yet, but that was something that actually came out fairly recently, so that's kind of cool. You can also author books. So there's actually a new package called bookdown, which is much better than the older system that you would have done to author books, which is using SWeave and writing raw tech, because tech gives you the ability to do cross-references across multiple files. markDOWN doesn't, and so markDOWN actually kind of incorporates the relatively simpler syntax of markDOWN, but it gives you all the cross-reference functionality that you get when you're writing in tech, for example. And markDOWN also, you can publish these books into a free bookdown hosting server where you can, if you're writing a book or you're writing some kind of manuscript thing, you can just publish it directly on the internet. And so that uses a package called bookdown. And so here's what the bare minimal book looks like. The changes are all specified in the YAML header. So you have this document class called a book, and then you have some kind of output. So you can create a Git book output or a PDF book output. And then under the body of the text, it's just regular markDOWN that you've been sort of hopefully gotten used to by looking at my slides.